Hello. Today we are going to take a look at Lesson 9.2, Investigation 3, a little more, working with word problems. We will be writing equations from the word problems and then solving them using backtracking. So first, take a look at these steps used to translate word problems into equations. If you already have these in your notes, there is no need to copy them again. If you do not have these in your notes, please pause the video and copy these 7 steps into your notes now. Okay, so if you already have these steps in your notes, we'll move on to some review. Go ahead and set up your notebook page with 9.2 Investigation 3, Home Learning. Please copy everything you see on this page. These 2 review problems are for you to do on your own now. Please pause the video, copy this down, and do both problems. When you're done, press play to see how you did. Okay, if you are listening, you are done solving these 2 problems and ready to see how you did. So for number 1, you are to solve using backtracking. We are trying to find out what n equals. First, we're going to undo the divide by 6 by multiplying times 6. 2 times 6 is 12, so we're going to put a 12 in that oval. Next, moving backward, we need to undo the times 4 by dividing by 4. 12 divided by 4 is 3. And finally, we need to undo the subtract 2 by adding 2. And 3 plus 2 is 5. So our solution is n equals 5. Make sure your solution is separate from your flowchart. As a reminder, you can check to see if your solution is correct by going forward in your flowchart, or even making the equation that matches it and plugging it in, which is what we did next. So let's take a look at number 2. In this equation, or flowchart I should say, you need to write the equation first. That means you need a variable. So we're going to start with the variable n. You can pick any variable that you'd like. First, moving forward, n plus 5 would go in the next oval. After that, n plus 5 is being divided by 4. Be careful here. Remember, when you're dividing or multiplying, everything in that oval needs to be multiplied or divided by. So in this case, we're taking n plus 5, and we're dividing all of it by 4. There are 2 ways to do this. I can put n plus 5 in parentheses and write divided by 4, or I can do n plus 5 divided by 4 with my fraction bar. Now I need an equation. I know that n plus 5 over 4 is going to equal this output 3. So I'm going to set my equation equal to 3. Again, my equation is n plus 5 over 4 equals 3. Or, if you use parentheses and one equation straight across, you might have n plus 5 in parentheses divided by 4 equals 3. If that's the equation you had, you should have solved it by using backtracking. Let's try that now. Okay, to solve using backtracking, I'm going to start with my variable, my unknown n. I'm going to add 5, which is what we see in the equation up top, or the flowchart up top. I'm then going to divide by 4, and my answer is 3. I'm going to undo the divide by 4 and do times 4 and get 12. I'm then going to backtrack and subtract 5, instead of add 5 and get 17. Oops, let's fix that. That should have been 7. Okay, so to double check, I'm going to take my answer, n equals 7, not 17, add 5, that would give me 12. 12 divided by 4 would give me 3. The second way to check is to make sure my equation is correct. So we're going to plug in 7, or substitute 7, in for n. So now instead of n plus 5 over 4 equals 3, I'm going to plug in my solution of 7 plus 5 over 4 and say, does it equal 3? 7 plus 5 is 12 over 4. Does it equal 3? And yes, 3 equals 3. It does check out. So now I know my equation is correct and my solution, n equals 7, is correct. We're now going to move on to work with some word problems. You may already have this worksheet in your binder. If you do, you may take it out. Pause the video if you need to locate this paper. If you do not have this paper, you can continue on now. In this video, we are going to first take a look at number 2, the roller coaster problem. Let's zoom in and take a look at it. 12 people are able to ride the Serpent of Fire roller coaster at one time. Write an equation that could be used to find the number of rides n if 60 people have been on the roller coaster. Use backtracking to solve your equation. How many rides have there been? Let's work on this one together. First, as always, let's make sure that we've decided on what the question is asking us and what our variable will be. How many rides have there been? That's what I'm trying to find out. This problem already told me that my variable needs to be n, which is going to be the number of rides. This should be in your notes. Next, I need to figure out what equation I'm going to write. Going back in the problem, I know that 12 people can ride the roller coaster at one time. That's 12 people per ride. I want to find out what equation I could write to find how many rides if there's been 60 people on the roller coaster. 12 people per ride. So now I'm going to write my equation. If there are 12 people per ride, I would multiply 12 times how many rides there were. So 12 times how many rides, n, is going to equal 60. I know I don't need to use that multiplication symbol when writing 12 times n, so I'm going to simplify it and write 12n equals 60. This is my equation. Now I'm going to solve using backtracking. I'm going to start with my unknown, my n, how many rides. In my equation, n is being multiplied by 12. That's all that's happening, and I have my output 60. So now I'm ready to backtrack. So now let's go backward, undo that times 12, and divide by 12. 60 divided by 12 equals 5. So n equals 5. I'm going to write my solution outside of the flowchart and then answer my question. How many rides have there been? There have been 5 rides. I have my equation, I have my solution, and I have my final answer answering the question. Okay, the next one we're going to start together and then you'll finish. Make sure you have all of this in your notes. Okay, here's problem 4, the school fair problem. The admission to the school fair is $2.25 for every game ticket. Samson spent $6.50 at the fair. Write an equation to determine the number of tickets n Samson bought. Use backtracking to solve your equation. How many tickets did Samson buy? Again, we read the problem, so now we have to decide what are we trying to find out. I'm going to underline the question. If you have the worksheet, you should underline the question on your worksheet. Now I need to decide on my variable. I need to know how many tickets Samson bought. Do I decide on a variable myself, or did the problem give me one? Looking back in the problem, it told me that I need to use n as my variable. And it says that n is going to be the number of tickets that Samson bought. Okay, now I know my variable is n, which represents the number of tickets Samson bought. Now I'm ready to make my equation. Let's take a look at this problem. The admission to the school fair is $2. That's just to get in the door. They also charge 25 cents for every game ticket. And when Samson was done, he realized he spent $6.50 at the fair. That is my total, or total spent. So I know that is going to be my output. So now I'm going to build my equation. The $2 has nothing to do with how many tickets were bought. That's the fee just for getting in. Then you have to add 25 cents, 0.25, for every ticket. And every ticket is n. 0.25 times n, and we can write it this way. Altogether, he spent $6.50 at the fair. I now have my equation. At this time, pause the video, set up your flowchart, and solve using backtracking. When you're done with your flowchart, write your solution and write your complete sentence as we did in problem number 2. Go ahead and pause the video and finish working on this problem. Have it with you in class. Okay, your final word problem for today. Take a look at problem number 6. If you have this worksheet, you can underline and work on this problem itself. Otherwise, take a look at it now. This is the sailboat problem. You need to write down your variable, write down the equation to solve. Then you need to solve using backtracking. And when you're done solving, write your solution, what your variable equals, and write your complete sentence. This concludes this video. Make sure you have these problems together in your binder, ready for school. Great job.